another law of sines problem. This is the one we have to keep an eye out for. This is our side-side angle case. If you're ever given just the side-side angle of a triangle, then this is that ambiguous case. Maybe we have one triangle with the information, two triangles, or even no triangles with what we're given. So we have to do a test to see how many triangles actually exist with this information. But we start the problem just like we would set up law of sines. We're recognizing, okay, this is side-side angle. We're going to keep that in mind, but it doesn't change the start of the problem. We're still going to take sine of angle 58 over its opposite side, which is 4.5, equals, now since we have side B, which is 5, we have to use angle B, so sine of angle B. Now we just cross multiply. 4.5 times the sine of B equals 5 times the sine of 58. Divide both sides by 4.5. We get 0.94227. So we know that the sine of angle B equals 0.94227, but to figure out what angle B actually is, that's when we use our inverse sign button on the calculator of that decimal. And when we do that, we figure out that angle B equals 70.4 degrees. All right, so we got 70.4 degrees. Right now, if I put that into the triangle, 70.4, I know that I have at least one triangle. The triangle that I have a picture of, that's what we're working on. We could get angle C and side C, and there's at least one. So how many triangles exist? We have one, but the question is there another one that exists? And this is what we have to do the test with. So to do our test, we have to use that 70.4 to help us out. So the test, what we're going to do is we want the angle that is supplementary to that 70.4. So we do 180 minus 70.4. We get 109.6 degrees. Now, if a second triangle exists, this 109.6 degrees is our new angle B in that triangle. So because we were given two sides and an angle from the original triangle anyway, that information wouldn't change in a second triangle. So I'm going to go ahead and add the original angle of 58 degrees. And what I'm looking for is, can we fit another angle in here? And that 58 degrees was angle A. Can we fit another angle in here up to 180 to see if we have another triangle? So we're looking to see if this makes us go over 180 degrees. If we're under 180, then we know we can fit in a third angle, angle C, for another triangle. So we add those together, and we get 167.6. Because that's less than 180 degrees, then yes, we do have a second triangle. And then to get the second triangle, angle C, we would take 180 minus that 167.6, and that would be our new angle C. In the second triangle, let me just kind of draw in here. Here's the A, B, C from above. Angle A is still 58, side B is still 5, and side C is still 4.5. That information doesn't change. But in the second triangle, we found our new angle B is this 109.6. And then we could subtract from 180 to get angle C from the two that we know, and then do law of sines to get side C if we had to solve for all that information. But how many triangles exist? We answer the question. There are two triangles that exist, and we got that from the test over here on the right.